In section 1.7, we're going to look at transformations of functions. This is a huge concept we're going to carry you throughout the whole year. So you may not be a pro at it right away, but it's essential for everything we look at, all the different functions we look at all year. The same transformation rules apply. So first, we're going to dive into looking at families of graphs or parent functions, is what we might call them. So everything we look at is just going to be a transformation of something, the most basic version of that, which we'll call the parent function. And we'll get into some of the main ones here. First, you got a constant function. This is like y equals 1, or if we had y equals negative 2 or anything like that. Just constant, slope is 0. It's constant, kind of boring. What we get into next is more your common ones that we transform. So a linear function, I realize that last one looked like a linear function, and it is, but it didn't have the true y equals mx plus b kind of stuff. It was just y equals 1 or whatever. Here we've got a y and an x variable going on here. So we've got the classic format y equals mx plus b, and we're going to try to transform these. This is your classic one. It goes right through 0, 0. A slope of 1 over 1 would be the most basic one. So basically, y equals x is your identity function or linear parent function. Absolute value, when we have absolute value here, the most basic one would just be like y equals absolute value of x. It's almost linear. It's kind of like one line coming down, then it goes back up, because absolute value makes everything positive. That's why we don't have any negative y values here. So that's why our range is everything bigger or equal to 0. It has this V shape, is what we're looking for. We're going to get into this notation here in just a little bit, talking about like what does the A value, if there was a number in front, like a 3 or a negative 2 or a 1/2, what would that do to the graph? Also, if there's a number inside the absolute value or inside the parentheses with a squared, how does that impact the graph? And then if there's a number outside of all of that, added or subtracted, how does that impact the graph? So you'll see this kind of general format can be applied to most of the parent functions we're going to see. Okay. Quadratic is something you should also be familiar with. This is an x squared. This is your most basic one, just a y equals x squared. Passes through the origin. Again, all positive values, but more curvy than an absolute value graph. And these are our parent ones. So we're going to do transformations. We're going to add in some of these other numbers in these different variable positions to see how they change the graph. We've talked about translations, reflections, dilations in your geometry class, and now we're just going to apply it to equations and see how the graph behaves. Did it get moved or translated? Did it get reflected? Dilation is either a stretch or a compression.